called the common logarithm. That was with a base 10. Now we are going to do base E. Okay. So we have irrational numbers like pi and square root of 2. We are going to introduce a new irrational number called E. Okay, this is called the natural base. And this is when we have a log with a base E. But we don't write it that way, okay? We write it like this, with a ln of x. So we say this is the natural log of x. E, just so we know, E is approximately 2.718. If you look on your calculator, you see where the logarithm buttons are?
Yes.
Okay, there's a button here, and if you press that button, it automatically gives you E with a place for an exponent. So if I said, oh, what's E to the first power? That's going to give you that approximation, okay?
How does somebody come up with this?
So
Yeah, I agree.
I can explain. Okay, I know it's complicated to explain because it uses things that you would learn in like a Calc 2 class. So like the seniors that were in Calculus BC this year learned how to derive this number. But yeah, it's not easy. It involves Calculus 2. I can't explain that part to you, but we use it. We actually use natural logarithms more often than we use common logarithms. Natural logarithms are used when we talk about also like exponential growth and decay. We use natural logarithms to solve those kind of functions. Okay, so it has to do with growth and decay. So just quick, some properties. Whoops. E. Get my highlighter. There we go. E to the natural log of x is equal to x. So it's almost like these kind of cancel each other out. Natural log of e to the x is x. And natural log of e equals 1. That we have to know. Okay, that's the important part. This is the most important because what happens when you have an exponent with a logarithm, we can move it to the front. So that would be x times natural log of e. But natural log of e is 1, so x equals x. Okay, that's a quick. All right, so we want to write each exponential expression into logarithmic form. What would that look like? How do we do it? Okay, so log base. Wait, what becomes the little e of 23 equals x. Now, I don't want to write it with a log with a base of e. I want to use, so I'm going to rewrite the natural log of, logarithm base e. I'm going to write that as natural log of 23 equals x. Okay, so I'm just replacing log base e with an ln, natural log. So, okay, do you know how we have things like if I said square root of x, don't we assume that there's really an invisible 2 there? So when we have a natural log, we assume that there's an invisible e here, okay? So let's look at the next one. E to the 4th power equals x. What would that look like? Of x. And then we're going to replace log base e with natural log of x equals 4. Now on the homework, if you want to go right to from what you were given to natural log, that's fine. Okay, so if you see, oh, it's an e, that means I'm going to have a natural log. Okay. Yeah, anytime you see e, we're going to think that's a natural log. Anytime we see ln, we're going to think that's there's a little invisible e there. So how would that look in exponential form? E to the
1.2528 power equals x.
Remember, what the logarithm is equal to, that's the exponent. And again, natural log of 25, there's a little e. So e to the x equals 25. Okay, now everything else that we're going to do, we've technically learned previously. So all the properties that we learned about logarithms are going to apply to natural logarithms. Okay, so what I mean by that, we want to condense this to a single logarithm. First thing we want to do is we want to take care of the numbers in front become exponents. So I have natural log of 1/2 cubed plus natural log of 6 squared. That look familiar? Right?
Mhm.
Yeah. A little bit. We had it on the quiz, right? Didn't we have some of that stuff on the quiz?
I think there's something like it.
Okay. What do we do when there's a plus sign?
Add them.
Multiply. So adding exponents, remember these are exponents, means you can. So I have, what's 1/2 to the third power? 1/8 times 6 squared is?
36.
Okay. What's 36 times 1/8? Well, that would just be 36 over.
4 and 1. 4.
So I changed it. So remember when we combine, so if this is plus, we could take the natural log of these two multiplied together. Okay, so let me just go back real quickly. This lesson. So if I have two things added together, I could combine them into one logarithm to multiply them, right? This one, if I have two things being subtracted, we can make them into a division. And if I have something in front, I can move it to the exponent. Okay, so these rules are for any kind of logarithm. So do you remember this stuff? This is what we did because we used this when we were solving. Remember, we'll move the 4 to the outside. If it's a subtraction, we change it to division. Right? Over here, we did this problem. We changed this plus to one logarithm where you're multiplying them. Okay, so we're literally doing the same thing, just with a natural logarithm. Right? Look familiar? Okay, 36 over 8, does that reduce?
4.5.
Or 9 over 2.
Yeah.
Okay, let's do the same thing here. So first I want to move natural log of 3 to the second power minus natural log of 4 minus natural log of y. Okay, so I have, now both of those are being subtracted. So any ideas what we would, what are we going to divide by? So first of all, 3 squared goes in the top. I'm going to put the 4 on the bottom. Then what? 4y on the bottom. Good. So anytime you have a minus, those are always going to go in the denominator. Anything that's positive goes in the numerator. And let's just, yeah, anything that's positive goes in. So the first one was positive. So let's say I had another plus something, that would also go on the top. So all positive natural logs go in the numerator. And any,
What if they're all part? They're not going to be, then you want to multiply it.
yeah, anything that's positive would all go in the numerator. Anything that's negative would go in the denominator. Think about it this way. Logarithms are exponents. If you have a positive exponent, doesn't that go in the top? And if you have a negative exponent, that goes in the denominator. So I know they don't look like exponents, but they operate just like exponents. So anything, this is a negative exponent, this is a negative exponent. They both go in the denominator. Okay, we're not going to leave it that way. I just want you to, what's the top? The top is going to be natural log of oops, 9 over, and that's it, right? I can't simplify the 9 over 4. Okay? Oh. All right. Calculators. I see.
Acquired.
Acquired. Yes, we need our calculators. Good. All right. Okay, we want to solve each equation. We want to round to the nearest 10,000th. So we have to have a calculator for these. Okay, first thing I want to do, I want to isolate e to whatever power it is. Okay? So isolate e to the power first. So treat this whole thing like a variable. So if that was like 3x plus 4 equals 10, what would we do first?
Subtract 1 both sides.
Subtract 4 from both sides. So we have 3e to the negative 2x equals 6. Now what? What do we need to get rid of next? The exponent. So I'm going to divide by 3. So we get e to the negative 2x equals 2. E to the negative 2x, though. Isn't there a negative? Okay. All right. Next, I want to get that exponent. So there's 2 ways I could do this. I can change this to logarithmic form, or I can take the natural log of both sides. So they're the same, it's the same process. One, right? What happens to the natural log of e? There's something I told you previously. What happens when I have natural log of e to a power?
Just X.
It's just going to be x. Well, in this case, what's the exponent? So I just have negative 2x equals natural log of 2. Almost done. Remember, we're now that we have, so we want to get this isolated. Last step is to just divide by negative 2. Well, this we need our calculator for. So I'm going to have natural log. We're going to press the control and then the E button, because you see above it, it has a ln. So we're going to have natural log of 2.
Divide by negative 2.
Oops.
Negative 0.366.
Do you see it?
Yeah.
Negative.
0.346.
Yeah, so don't try to cancel the 2 and the negative 2. All right, we have to do the natural log and then divide it by negative 2. Okay. How about the next one? What do we have to do first?
Add 12 both sides.
Add 12. So I'll have 3e to the 4x equals
27.
27.
And then
E to the 4x equals
9.
9. Now what? We got to get that 4x, so we're going to take natural log of both sides. What happens on the left side? Just gets 4x. So what's x going to be equal to? Natural log of 9 divided by here. So these like kind of cancel each other out. So we just end up with the 4x.
Yep.
Okay. And then, oh, did anybody plug that in?
0.54931.
Everyone agree with that?
Here is the 1. Shoot.
Oops.
Is it in?
Wait, what? Say that again.
0.5493.
5493.
Yeah.
Okay. Good. Any questions? Good? All right. Now we're going to solve a natural logarithm equation.
Okay, ln and e cancel each other out.
Yes.
Yeah, for x.
Yes.
But ln does not cancel on the other side.
Correct, because you don't have an e on the right side. If there was an e on the right side,
Cancel both.
well, what would natural log of e be? I told you that was always 1, so I would have 1 on this side. Okay? Listen, if you want, remember how you can put the exponent in the front for x, but what did I just say natural log of e is? 1, so 4x times 1, it's just 4x. Okay, so I don't usually go through that step because that's part of the learning the properties. Okay, now what we want to do is we want to get this in exponential form. So we're going to isolate, now we're going to isolate the natural log. Okay, so I got to get rid of the 2. Now you can either move the 2 to the exponent or I can just divide both sides by 2. So I have natural log of 5x equals 3. Okay. Now, what I want to do is I want to rewrite this in exponential form. So remember how there's a little invisible e here? What would that be? It would be e to the power of 3 equals, okay, I'm solving for x, so what's the next step? Divide by 5. Now remember, e is an actual number. It's about 2.7. So if you think 2.7 to the 3rd power, yeah, so it's less than 3, so it's going to be something less than 27, but we don't know what it is exactly. So that's why we're going to use our calculate, oops, not control. So find that e button. It's right down here. So divide by, what were we dividing by 5? 4.0171. 171. Good. All right. So that's what I was saying. Like a lot of this is just repeating stuff that we've done before. It just looks different because we're introducing this new concept of the natural log and the base e. What do we do on the next one? Multiply by 3. So I have natural log of x equals 6. Now what? We want to, so think there's an invisible e. I want to rewrite this in e to the 6 equals x.
So now we just
What do you think? That's going to be,
um
so e to the, right. So
403
what's nice about this one, I just have to do e to the 6th power. I don't have to like divide by anything. So I'm just going to plug that in. 403.
0.49.
Right, but we want to go to, oops,
Oh,
428.
Yeah, my calculator just rounded to the
Oh.
thousands.
Okay.
Yeah, for mine did that too, but you usually do it like the.
If that's the case, you guys should check your settings to make sure.
There's a certain amount of digits.
Okay.
you go to before-
Do you see, do you know in your settings, like if you go to,
Oh, yeah.
go to settings, go to document settings?
Yeah. Float 7.
Yeah, if you can change this number to a bigger number, it'll go to more decimal places. So, like, you can even change it, like I'll go float 8. That'll just make it go to 8 places on your calculator or more places.
Yeah, first I had mine now, like.
Does it work now?
Mine's
Yeah.
float 7.
Yeah, I would make sure yours go
Six,
to
maybe.
float, probably float 8 is probably the best, or bigger,
There we go.
okay?
That way, what do I press?
Just say make default.
I did it still did the same thing.
Okay, do you remember when we did the compound interest? I didn't have it on the quiz. That was one thing I didn't have on the quiz, but it will be on the test, where you have, like, it's accumulated monthly or yearly or quarterly. Okay, another way, and this is usually the more common way, what if you put something in an account and it's continuously being compounded, okay? This is the formula that we use. A is the amount after T years, so T is time. P is the principal amount. That's the amount that we put in initially. And R is the interest rate. Okay? So some people call this APERT because it just looks like, right? A equals PE to the RT.
Miss Amy was just talking about this yesterday.
Oh my goodness. That would be easy for you to remember. Alpert.
Miss Amy was just talking about this yesterday.
Oh,
Wait, let's see. What
what's this say?
Talking about T being time.
put your caps lock on?
Was.
Oh.
Well, how do I change this? This is the shit.
Okay, let's look at some examples here. So suppose you deposit $700 into an account paying 3% annual interest, compounded continuously. Anytime you see that word continuously, we know we're going to use the one with the E. Yes, sir.
So like that would mean like you put $700 in your account and then you get 3%, so it'd be 721. Then 3% of 721 would just still 3%. You understand what I'm saying?
No. Say that again.
Right.
So you put $700.
And then after a year, you get 3% interest, which means that you have 721. And then the next year, it would take another 3%.
Okay.
So what it do?
So what you're doing is you're saying it accumulates all the interest at the end of the year.
Yeah.
But what I'm saying, so that's like yearly. This is different. This is so
this would be like every day you get.
every day you get a percent of what you had. Okay, so it's continuously. So the next day you'll have an incrementally more. Okay,
Why would anyone do
but
this?
it's well, this is the most common way. This is the most common way. So if you check your bank account, right? Your bank account is continuously changing, right? If you have a savings account or something or whatever, it's continuously changing. It's not like it just changes all of a sudden at the end of the year. Okay? And that's how a lot of like investments work. They don't, you're like, if your parents have investments or whatever, it doesn't just change at the end of the year. It's changing constantly. Like if you have a college savings, right? You get quarterly updates, but it's constantly changing. Does that make sense? I don't know if you guys ever talk to your parents about these kinds of things, right? College savings or whatever, they go up, they go down, but they're constantly changing. It's not like it just changes one day. So that's why this formula is really important. So that's where this E is more important. Natural logarithms are more important in real life than the other logarithms that we learned about. So these, you know, one day you get a mortgage, right? That's going to be an APERT. Okay.
Rather than just getting interest, couldn't you just like buy a bunch of stocks from one company to raise the price of them and then sell them? Oh.
Okay. Some things are legal, some things are illegal.
That
Let's
is
not get
one of
into
them.
the illegal business. Okay.
That is not one of them.
All right, here's our formula. A is what we're trying to find. We want to find the amount after your principal amount, which was 700. E, okay, if it's 3%, we want to write that as a decimal, 0.03 times 8. So we want to see how much we have. So we'll just type, all I need to see on the homework, show me the setup, and then you can just type it all into your calculator at once. So I'm going to do 700 times E to the 0.03 times 8. You might be able to just write E. There we go. And we want to make sure, we're talking money, so let's go to the nearest cent. So $889.
So after 8 years,
That's all you get. Yep.
not a lot. Starting from 700.
Starting from $700. So 3%, it's only 3%, which is why when you down the road, your parents probably now, when they're looking at investing in something, they want it to be like, if you can get in like something like a 7%, that's like pretty good. That's really good.
What if
Right.
inflation is like 6?
Then you're, yeah. Well, inflation's not going to be 6% every single year. Okay, we've been hitting inflation marks we know that have been higher than they've been in decades, right? So unfortunately, right, we're in a time when we're combating that. It's not going to be that every single year. Okay. All right. Let's not be doom and gloom. Let's see. How long will it take for the balance in your account to reach at least $1,200? Okay, so now, all right, this is our amount. We want to see how much will it, right? That's the kind of question you're asking, because if you're looking for an investment, right? So again, it's a, think like, yeah. Juliet's last name without the L. Alpert. Okay. We still are investing. So if you're thinking ahead, okay, by the time you graduate high school, your parents want to have a certain amount in your college fund or whatever it is, right? So obviously $700 isn't going to be much, but let's see, to go from 700 to 1,200. So that means my rate is still the same, but I'm solving for T. Okay, so this,
Divide all that.
divide all that by 700, right? We're going to isolate e to the power.
Oh, this
Wait,
is
can't
the
you,
same
can't you
question.
divide
Oh.
everything by it?
Yeah, that's why I was like, where'd you get?
So
This
wouldn't
is
it
the
be
same question.
12 or 7?
Okay,
Yeah.
so in the last question, I wanted to know if I put $700, how much will I have after 8 years? Now I'm saying, okay, I'm still investing my 700. I want to see how long it'll take for it to become 1,200. So I'm just going to make that 12 over 7, right? Canceling out those zeros. Okay, what did we do on the previous page when we had to solve for the exponent? How do you get rid of the e? What cancels out an e? The L, N.
You can just add it.
Right, whatever you do to one side, you have to do to the other to balance the equation out.
Oh, because you want to make it equal one.
Yeah, so exactly, what's going to happen on the right side?
I'm gonna go.
We're going to get just 0.03 t. Now I still have the natural log on the left side because I don't have an e on this side, so I have to just leave it like that. Now we get to divide, and I know it's going to be disappointing to see how many years it's going to take.
Yeah.
Anyone?
Oh, you're not gonna be alive. Nobody's big numbers.
Let's see. So I have control. So natural log of, what was it, 12 over 7?
Mm-hmm.
And then I want to divide by 0.03.
Wow.
Wow.
That's
About
sad.
18 years?
That's really sad.
Oh, you want to sit around?
Yeah, I'll say,
Can I do T and then the squiggly equals?
sure. So it's going to take 18 years to get $700 to turn it into $1,200. But if you think about that, think about if you start with $7 million to reach $12 million, 18 years,
But yeah, you're not gonna.
right? So it makes a difference about like how much you're investing, right? It's a different story when you're looking at that. Okay, last one here. How much would you have to be deposited in order to reach a balance of 15 after 12 years? Okay, so I'm now asking what should be my principal amount. Okay, so these are the kinds of questions too. And this is, I want to have an amount, T years. So a PERT, so 1,500 equals PE, we're still 3%, same question, times 12. So this whole thing right here, that's a number. Remember, this is 2.7. So this whole thing, I can just divide it, right? So if I just divide, now if you want to multiply, what's 0.03 times 12? 0.36. Right, makes sense? So this is actually a lot easier than the last one because this is a number, so we treat it like a coefficient. So just go ahead and divide. Let's see. 1.
I got the same thing.
Yeah, I got 1,046.
Got it. Yeah, $1,046.51, right?
$1,046. What did we say? And 51 cents.
Yes.
Okay. So this is working backwards. We're saying, okay, in 12 years, I want to have this much money, and this is my interest rate. How much do I have to put in? Okay, so that's also a good question. All right.